10.2 Trigonometric ratios of 100 degree plus or minus alpha, 360 degrees minus alpha, and negative alpha. In this session, we have A, quotient relation and square relations. Please refer to the notes 10.a and let's see how to simplify the trigonometric ratios. When we talk about this section, that means now sine, cosine, tangent for certain size of angles, whatever the size, we still can find out the trigonometric ratios. For example, here, cosine 440 degrees, sine negative 30 degrees, sine 150 degrees, cosine 240 degrees, and tangent 315 degrees. Before you've learned in junior form, all angles are the acute angled. All angles are the acute angled. And now, any angles that we can find now. Before we find the angles, let's talk about the reference angle. Okay, reference angle. Here the reference angle alpha in between 0 degrees up to 90 degrees. So for angles greater than 90 degrees, then we need to consider the reference angle to help us find out the ratios. So try to know how to find the reference angle. For example, here, if theta is 45 degrees, okay, then this is also alpha. So alpha also is 45 degrees, okay. If theta now is 150 degrees, that means here. Then, where is alpha? Remember, when you want to find the alpha, try to have a look x-axis. And what is the size of the alpha? This one. Okay, start from x-axis to the terminal side. So this one is alpha. So this is 30 degrees. Okay, 30 degrees. Because this one is 150, so that means alpha is 30 degrees. Okay? How about the other two? 225 degrees. So here is 225 degrees. So where is the acute angle? That means the reference angle. Here. Start from the x-axis, okay, then find the acute angle, here alpha. So this one is 45 degrees, okay. 300 degrees. About this, okay, 300 degrees, theta equals to 300 degrees. Then where is the reference angle? Again, compare with the x-axis here. So we count here, alpha. So here alpha is 60 degrees. 60 degrees. See? So when we talk about this one, that means, okay, let's have a look. 150 degrees, that means this one is 180 minus 30 degrees. 180 minus 30 degrees. Okay, how about this one? This one you will think that it's 180 degrees plus 45 degrees. 180 degrees plus 45 degrees. How about 300 degrees? You can think it as 360 degrees minus 60 degrees. Okay, So you see that those angles greater than 90 degrees, for example this one, we can use a reference angle related to 150. This one, 225, I use a reference angle 45 degrees related to 225. 300 degrees, we use 60 degrees related to 300 degrees. Okay? When we find sine theta, cosine theta, or tangent theta of angle greater than 90 degrees, then what should we do? Now have a look here. Consider trigonometric ratios of one of that. 180 degrees minus alpha, that means now in quadrant 2. Think about it. Okay? So here, whatever, do you remember the definition of these three trigonometric ratios? Yeah, sine theta as y over r, cosine theta as x over r, and tangent theta as y over x. Yeah, related to the coordinates of the point P, right? So, if now theta here, okay, theta here. So 180 degrees minus alpha, that means in quadrant 2. So the reference angle alpha is here, okay? Then what's the sine ratios here? And you see that's y over r, that means b over r. B over r actually same as sine alpha, okay? Maybe you say that here is like the alpha, the size just the same, right? Okay, so b over r, okay, because the length is r, okay? Then you see sine 180 minus alpha equals to sine alpha. You think it, okay, sine 150 gives you an example. So this one is equals to sine 180 minus 30 degrees, right? So sine 30 degrees, just the same, okay? How about cosine? Cosine 180 degrees minus alpha, x over r, right? And this one, if I put it in quadrant 1, you see x over r is e over r, so negative cosine alpha, okay? Here, an example, 150 degrees, okay? You think it as cosine 180 minus 30 degrees. And this one actually related to cosine 30 degrees. With negative sign, yeah. Right. How about tangent? Tangent 180 degrees minus alpha here is y over x. That means this. Okay. If alpha I put back in the quadrant 1, y over x is b over a only, right? So negative b over a, so I can write as negative tangent alpha. And let's see, tangent 50 degrees. That means like this. 180 minus 30 degrees. So this one, negative tangent 30 degrees. Right. Negative tangent alpha. If tangent 180 minus alpha, they're equal. Then later on, we'll have a look at how to find sine theta, cosine theta, or tangent theta of angles greater than 90 degrees. Okay, and here we'll have a look. Now I use another apps, this one, remember? Okay, GeoGebra. Here we have a unit circle here, and this one is 30 degrees. You know, here is 30 degrees. Okay, 45 degrees, 60 degrees. And remember, cosine, sine, or tangent actually comes from the coordinates. Okay, cosine, which comes from here, x over r, and sine, y over r. So you see that this one, 60 degrees, root 3 over 2. Then, if the angle greater than 90 degrees, then what happened? For example, here, 150 degrees. Okay, 150 degrees. Then, where's the reference angle? Yeah, correct. You count it from the orange triangle. Okay, so let's see about this. And just now we say that this one is the reference angle alpha. That means alpha is 30 degrees. So sine 180 degrees minus 30 degrees. Okay? And you found that this relation actually is same as 30 degrees. Do you know why? Yeah, here is y over r, and the unit circle r equals to 1. So here 150 degrees also equals to 1 over 2. Can you see that? Okay, that means same as sine 30 degrees, so 1 over 2. Okay, and here you can think it as, okay, this one quadrant 2, sine theta in quadrant 2 is positive. Okay, therefore when we know about the reference angle, then it's a positive relations. Okay, the value is positive. Okay, then how about cosine? Cosine 150 degrees. Let's see. Cosine 150 degrees, we can say as cosine 180 minus 30 degrees. Right. And use the same triangle, the orange one. Right, the reference angle now here 30 degrees. Same as just now, 30 degrees. Okay. So that means this one related to 30 degrees. However, please remind yourself here, cosine theta in quadrant 2 is positive or negative? Yeah, negative. So here is negative sign. Okay, and therefore this one negative root 3 over 2. Negative root 3 over 2. Okay, clear? So in the same time, if you ask me, how about tangent 150 degrees? How about tangent 150 degrees? Then you see that tangent 180 minus 30 degrees because related to the reference angle 30 degrees. Okay, and you need to think tangent theta in quadrant 2 is negative again, right? Therefore, this one related to tangent 30 degrees with negative sign. So at the end answer is what? Yeah, this one is negative 1 over root 3. Correct. Negative 1 over root 3. Or you can write as negative root 3 over 3. Okay? Is it clear? Let's just have a look one more. If this one cosine theta equals to 420, then what's this? Theta equals to 420, and you see that this one actually is cosine 360 plus 60 degrees, right? So actually this one same as cosine 60 degrees because we use the same triangle here, okay, the orange one, and because it lies on quadrant 1, so same as cosine 60 degrees. So this one, so in the same time 420 degrees, you can write it as this. Here the reference angle is 60 degrees. Okay, that means here 60 degrees. Okay, so sine 60 degrees, oh sorry, this one should be 1 over 2. Okay, sine 60 degrees is root 3 over 2. Yeah, root 3 over 2. And tangent 420 degrees will equals to tangent 360 plus 60 degrees. Same as the reference angles is 60 degrees. So here tangent 60 degrees. Therefore this one root 3. Okay? Have a look. The angle theta lies in quadrant 3. Here, cosine 240 degrees. Okay. X-axis here. Then where's the reference angle? Correct. This one is alpha, right? So here we can write as cosine 180 degrees plus alpha. Okay, plus 60 degrees, right? Okay, so you need to think. Okay, here is the reference angle, and now think. The angle 240 lies in quadrant 3. Then what is cosine theta? Positive or negative? Well, this one negative. So here, negative cosine 60 degrees. Okay, negative cosine 60 degrees. And you see that's here. Cosine is the x coordinate, that means negative 1 over 2 over r. R is 1 because it's a unit circle. Okay, so here negative 1 over 2. Okay, how about sine 240 degrees, you think? Again, sine 180 plus 60 degrees. Okay, here is the reference angle, and you need to think now. Quadrant 3, sine theta is positive, right? Very good. Then you're wrong. It should be negative. In equation 3, cosine and sine also negative. So remember this one, sine 60 degrees, negative value. Okay, negative value. So as a result, negative root 3 over 2. Negative root 3 over 2. How about tangent 240 degrees? Tangent 180 plus 60 degrees. Okay, so here is the reference angle. Okay, alpha and alpha. Think about tangent. Equation 3. Tangent theta is, yeah, this time is positive. So tangent 60 degrees. Okay, so as a result, y over x. Y over x. So this one is root 3. Okay, let's have a look in equation 4 angles. Tangent 350. This one 350, you see that here. And where's the reference angle? X-axis here, and we need to have a look. Reference angle alpha here. This one, that means equals to 45 degrees. Right. You can write as, okay, tangent 360 minus 45 degrees. Okay. So for this one, reference angle 45 degrees, and you need to think. Equation 4, tangent theta is negative, correct? So tangent 45 degrees with a negative sign. Okay? So here, negative 1 is the answer. Can you solve this true question? Sine 315 and cosine 315. Yeah, in the same time, reference angle also 45 degrees. So I write as 360 minus 45 degrees. Again, think. In equation 4, sine theta is negative, correct? So here, sine 45 degrees and equation 4. So as a result, negative root 2 over 2. Okay, the last one, cosine 315. Cosine 360 minus 45 degrees. Again, reference angle alpha. Okay. Yeah, need to think. This one is quadrant 4, and then cosine theta is, only this one is positive, right? Okay, so negative cosine 45 degrees. So it's positive, not negative, sorry. Too fast. So this one, root 2 over 2, because this one is positive. See? Okay. Because this one is negative, see? Negative, see? Okay. So in this session, hope you understand in different equations, then what should we do to find the trigonometric ratios? Actually, we need to make use of the reference angle to help us and then find the trigonometric ratios. Okay?